Ladies and gentlemen, I suppose we should start. I think the rest of the spectators will come soon. So we continue our today's conference. We are talking about barriers, opportunities, and strengths in robotics from different point of views. And in this, the last today's session, we will talk about robotization of industry in the eyes of Fanuc company. So let me introduce the first speaker, Jędrzej Kowalczyk, who will start with the session, and then the next speakers will be invited one by one. And I think that this session also will be, as all previous ones, very interesting for you. So floor is yours.
Thank you very much. Good afternoon, ladies and gentlemen. We would like to present you together with our partners a bit about the industrial automation and the horizon which should come soon. And mostly what we expect is in a general industry. We should think more about the respect for people, the sustainability, and of course, the resistance to the external factors. And we would like to try to explain how we seen it or how we can prepare for it. So I don't want to educate you today about the industrial revolution. I think this is a common topic, but just would like to highlight how quickly the changes are taking place and how we could see that from the concept of Industry 4.0 to the already Industry 5.0, just in one decade, we already seen a big change in the way of the thinking. And here are some examples. Mostly, the most important is that in the Industry 4.0, we focus very much on the just connecting the machines, just on the some smart ideas. And in the Industry 5.0, we need to think much more on the delivering of the custom experience. And the biggest difference is in the manpower. That normally we try to do everything to reduce the manpower in the industry, and right now we back again with the manpower to the factories. So if you take a look on those examples, there is two main issues, main things. One is behind of it, which is the artificial intelligence. So in the Industry 5.0, mostly we will focus on the artificial intelligence, how it can support robots in future, and also the people and the human touch much more. So we learned just in the last decade that the holy grail of manufacturing is also the human touch, that companies no longer automate their work at any cost, but rely much more on the people, on the humanization, because we could observe even a big projects on the world, which we forget that without people we cannot do much. And one of the biggest companies in automotive and all others brands make mistakes because they try to invest in automation too fast and completely not thinking about the human resources. So the super intelligent enterprises are the combination of those two elements. One is the robots, which can give us a speed, accuracy, reduce the bottlenecks. And the second one is just people, which thanks to the cognitive thinking, the human intelligence, can really improve the manufacturing world. As I said in the title, the vision which we have and would like in the next presentation also explain a bit is focus on the human-centric. It's how to stay sustainable because we've got the same sources like our future generation would have, but also the resilient, like we seen pandemic, COVID-19, or the geopolitical changes around us makes that many companies, unfortunately, the break-even point cross and couldn't stay in the business anymore. So robots already can, for example, see by the vision systems, they can feel by the force sensors, and thanks to that, we can improve the robots in many areas, which were quite tough to do it without the sensors around it. But thanks to the AI, the robots would be installed even in the areas where actually are still green fields. And we can see in our observation that the most important thing would be the AI around the robotics, because thanks of it, robots with the computer vision could recognize the surroundings, or thanks to the better servo motors parameters, they could make the processing of the parts, like polishing, adapt to the polishing for the individual production. And also the motion control and navigation of the robots will be much more done by robot itself. I mean, robots can already program themselves without any human touch, and robot can recognize the surroundings and work around it just like the production process expect of it. Also, the NLP, the natural language processing, and with artificial intelligence, with machine vision, already we've got some examples. Unfortunately, still in very, very rare application, but this makes robots much more autonomous, and they can just work with the management system of the production and realize the task according to the production needs. So those is about the single robots, but we need to know that even with the best system, with the best single robots application, generally today the production has no sense, because the production is like a chain. So we need to, like we heard already on the nice presentation before, we need to know that everything must be not only connected, not only monitor, because this is the past, but also the systems should support with the way of thinking, like artificial intelligence can support us with the analysis of those huge amount of data, and then we should know how to drive the system. So this is an example of the usage of 3D vision system with the machine learning, where robot can program by itself without any human touch. And next, the robot can take the workpiece from the bin. And what is also very nice, that the robots which learn this task can share the knowledge between all other robots. So normally single robots learn around 8 hours, but if we've got like 4 robots, they will learn just 2 hours. So we need to generally think how, thanks to the robotics, we can answer to stay strong, and remember that we need to really focus on the resources which our planet offer, but even the energy, which is very expensive, but also even sometimes difficult to get, how we can protect for it. And I would like, with our partners, answer for those things today. So please, I would like to invite Mateusz, who will also present about the robots itself and evolution.
Hello, good afternoon, everyone. Thank you, Jędrzej. My name is Mateusz Mroziński, and I'm representing FANUC as well. May I have my presentation, please, meanwhile? So I'm representing FANUC, so the Japanese producer of industrial robots and robot machines and CNCs. And I would like to invite you for a quick journey for the evolution of industrial robots, but also for the quick discussion about the possibilities of industrial robots as they are today. So, but we are not going to talk only about the past and about the presence. We're gonna have a look as well for the future very briefly. 25 minutes is not too much for more than 60 years of industrial robots evolution. It gives more or less 1 minute presentation for 2.5 years of industrial robots history. But let's have a look and let's try. I'm going to use the example of FANUC, because as FANUC, we started to build industrial robots in 70s, starting from 1950s, actually, with the building first NC and servo drive systems. So if we have a look just very, very briefly, not to go too much into the details, but let's have a look. So FANUC created the first NC system in 1956. In 1974, FANUC used the first industrial robot on their own production plant. So FANUC is using its own robots at its own production plants in Japan. This is very important. In 1977, actually, the first Model 1 of FANUC industrial robot was released. It was very, very simple 3-axis robot for a simple handling applications. And what you can observe nowadays are rather articulated robots. So the robots with the rotary joints and with rotary links. And this kind of robot, S Model 1, was released in 1981. Next, very quickly, 1992 was the prototype actually of the first so-called intelligent robot. What do I mean by intelligent robot? The intelligent robot is the robot that can observe the environment, can measure some things, can sense and collect some data, and can take some decisions on that basis. I will explain that a little bit later on. So it was the prototype actually of the first intelligent robot. 1999 is actually the first complete industrial series of intelligent robots. And let's have a look what was further. So starting from 2000, actually this series of R2000 robots is actually the most common and most popular of FANUC robots family. These robots are mainly used in automotive tier 1, but not only. For spot welding, for heavy handling applications, these robots can handle up to, nowadays, 270 kilograms of payload. And in 2003, as you can see, FANUC moved on a little bit, so created the first, not only the robot, but the system without human operator, I mean machine tending. So the robot was standing in front of the milling center and was loading, unloading the part into and from the milling center in this case. 2008 is the super heavy payload robots, so M2000. This is interesting, this kind of robots, my favorite actually, these are handling the biggest payloads in the world right now. So this biggest unit can handle up to 2,300 kilograms of payload nowadays. And by the way, this is the world record still. Later on, 2009, Genkotsu robots. These are the Delta robots. You're gonna have some example in some video example in a couple of minutes. So the quick robots, the parallel linked robot arms for quick sorting, pick and place, and so on. So every operation that requires really, really short cycle time. Later on, learning robot and 3D area sensor in 2012. We're gonna have again some examples for this later on. And please have a look at 2015 collaborative robots. I don't know if you are maybe familiar with this kind of robots family, but the collaborative robots came up, cobots, so-called cobots. So the robots that can work side by side with the human operator directly without any mechanical safety fences around. This is the idea behind the collaborative robots. They are slower a little bit than the common industrial robots, but still very useful for some kind of applications. And SCARA Robot 2017 is just another construction of 4-axis robots for packaging, pick and place, sorting, and so on. So this is briefly the quickest history story I could ever have. But this is briefly the FANUC story over here. But please note that during all of these years in the past, we noticed that mechanics is not as important anymore. So of course, producers are still trying to design the compact, lightweight robot and so on and so on. But what is really important now is the software and the powerful software. As Jędrzej mentioned, artificial intelligence, all the sensing equipment. So producers and with the FANUC on the top decided to go with highly advanced algorithms to give the robots possibility to feel their environment and to take the proper decision on that basis. But still, the role of the robots in the modern industry, I think you all are aware that the design of robots and their construction and the new models are dedicated or are maybe designed indirectly by the market requirements. So the market decided they want to have the flexible robots. For example, it is not anymore sufficient to have the robot that is performing the same task 24 hours and doing nothing else. What is really important and what is really powerful now is, for example, the possibility to move the robot from one place to another and quickly adapt it to the completely new task. This is what is really counting now. For example, for this, we have this collaborative series with the graphical teaching method and with the moving the robot arm and teaching the program like that without writing any program commands, for example. So this is really important now. For sure, the robots still are designed for handling the heavier tasks, the dangerous tasks. The robot can really help the production plants to deal somehow with the market fluctuations, for sure, especially with the lack of human resources. And what is the future? Again, working side by side, shoulder to shoulder with the human operator. That really might be the future. But still, we have to remember, for some dedicated operations, collaborative robots are perfect. For another, they are not. We will still have some examples. By the way, this is the important or interesting number, as you can see on the bottom right corner. It is almost 2.5 million robots working in the world now. FANUC, by the way, have around 760,000 of the units installed in the world, which gives around 22% of all of the world of the working units. So this is quite important. And now let's have a look for the different kind of applications and tasks that are being performed by the robot. So if I were to mention you the most commonly used applications and kind of applications for the kind of tasks for the robots, I will mention pick and place, palletizing, packaging applications. I would also say about assembling applications and also processing applications like deburring, polishing, grinding, and so on and so on. And what can be the example for this? It might look like this, for example. So this is the common, typical pick and place application for the Delta robot. As you can see, quite fast unit, which is, let's say, chasing or tracking the part on the conveyor belt and is picking the part without necessity of stopping the conveyor, actually. This is quite simple software package for it. It's called IR-Pick tool, and I will summarize it later on. But this is first nice example. We have a lot of palletizing applications. These are mainly the heavier payload robots, 4-axis robots mainly, that are lifting up to 300, 500, 700 kilograms of payload. Quite common applications, for example, in the food sector, but not only, again. So this was palletizing application. If we have a look on some example from the industry, not only the demo applications, we would, for example, have a look on this kind of applications where, for example, smaller units are doing the pick and place and packaging job, like the SCARA, 4-axis SCARA here, is handling the bags. And in the second step, we normally have the big robot like this with the dedicated gripper. As you can see, the construction of the gripper is really crucial in most of cases, which is doing the actual palletizing job. So this will be the first example. Sorry, I will skip it a little bit and go further, not to waste too much time. So the second example we could have is again palletizing, still staying in that sector, where, for example, the first palletizing robot, as you can see, is handling also the pallet, not only the product. So we are handling the pallet, we are handling the cartonnage paper sheet first, and then we are starting to palletize actually the products. For example, the cartonnage boxes or any other type of product. So this is actually the palletizing. As you can also notice, we do not have to grip the workpieces single one by one. We can also take the whole row or the whole layer of products with the robot easily. And after this, in this example, actually, we have the two small colleagues that are applying the cartonnage corners before stretching the pallet around. So this is quite a nice example for not really easy actually task, especially in this case. They are using vision sensor, but I will speak about the vision later on again. Next applications are again handling, machine tending, which might look like this. So loading, unloading the parts into the, for example, milling center, not only, but for milling center at least. What is interesting, as you can see, these robots are cooperating with each other, quite close to each other. You might consider hitting the robot, one robot to another. Some human operators are trying even to do some crash test between the robot. The system will not allow to do this, and this is another safety software package or safety additional option for the robots to avoid the collision between the robots. So the robots are taking care of themselves, not to get a collision between each other. This is another nice example. Spot welding, arc welding, another typical example, especially again in case of automotive, but again not only automotive. So that will be the typical arc welding application with the ArcMate series of robots that are designed actually to do the arc welding job. This one. And all the process applications like polishing, deburring, grinding, and as I said, milling, and so on and so on. We would have another kind of applications like, for example, washing, assembling, painting, and so on and so on. There are actually plenty of different kinds of tasks to do. So these were, I would say, the most popular, the most typical we can imagine. And what you can see now is just the collaboration between the human operator and the collaborative robot. And we have actually also a nice example for this, because if we compare the collaborative robot and the industrial robot, a common or a conventional industrial robot, there would be some advantages and the drawbacks. So the main disadvantage of the collaborative robot is that the unit is normally a little bit slower. Why? Because the robot have to stop immediately when the physical contact between the robot and human operator occurs. So if I touch the robot, it has to stop immediately. You can actually test it. We have the CRX with us today, close to the main hall, close to the door. You can visit us and you can actually test and try the contact stop function. But on the other hand, again, the robot does not require actually the mechanical fences around the robot. We have some nice example also for this, because if you, for example, use Audi, or if your favorite car is Audi, that would be a nice example. I don't know your preferences. But in this case, as you can see, this is the real case from the production plant of Audi. As you can see, there is a plenty of heavy duty for the robots, heavy tasks, typical repeatable applications for the robots, like spot welding, like arc welding, and so on and so on. But on the other hand, you will notice that Audi also decided to use the new approach in case of robotization using the collaborative robot, this one. And in this case, you will notice in a few seconds that the human operators, they are performing their job, they are doing their job, and the robot is doing their job just next to them. So they are performing some manual things, and the robot is doing the vision inspection of the process without stopping actually the work of human operators. And this is the idea of the collaboration between the human and the robot in a full application. So this is another example. So to summarize a little bit, I would say that we have the robot on the right-hand side, as you can see, but the robot is just a mechanical unit, and the robot can do only the simple things without actually equipping the robot with the ready-to-go additional packages. As you can see, we have 250 options, software and hardware options, to extend the possibilities of the robots. And very commonly used additional packages for the robots are the senses. If we equip the robot with the vision sensing and with the force sensing, then we can get so-called intelligent robot. As I said before, we call intelligent robot the robot that can take its own correct decisions by itself. So in this case, we can use the IR vision. It is called integrated robot vision. This is the vision system produced by Fanuc. We have this IR pick tool. You remember the example with the Delta with the fast application? It was the IR pick tool. It was the ready package for tracking the parts on the conveyor belt. And we have the IR calibration. So another vision-based software tool to make additional calibration between the robots. For example, I wouldn't like, again, go into too much into the technical details. So we have the vision options. As I said, 2D vision to locate the parts on the surface, on the plane, but we have again the 3D vision sensor. And actually, you could already see some example on the previous presentation, but we are talking here about the 3D, about the bin picking application actually. So the robot is able not only to locate and to find the part on the surface, on the plane, but the robot is again also able to look into the bin and to take some proper decision to take the part out of the bin and place it correctly on a dedicated place. Is it only locating? No, it might be also the vision inspection. So the robot can at the same time decide if the part is okay or not okay. So the robot can perform control of itself and the control of the moving parts. It was the bin picking. How about welding? Another example. If the robot welds for a long time, for example, for a couple of hours, then the natural thing is that the welding tip is being shifted a little bit or a little bit damaged. So what can we do in this case? The robot can go inside the yellow box. As you can see, there is a camera inside. The robot is taking one, 2, or 3 pictures and is adjusting the program to compensate the shiftness of the welding tip and is performing further welding operations correctly, knowing that the welding tip is a little bit shifted or damaged. This is called eye vision torchment, and so on and so on. We have plenty of these kind of examples. Another examples will be, for example, the force sensor. So in case of, as I said, polishing or assembling or applying any force to the workpiece by the robot, it can control itself, and the robot can also control the workpiece not to damage it, for example. So that will be the contact force applications. And last but not least, hand guidance and the plenty of possibilities of teaching the robot new programs, new movement with grabbing the robot arm and moving it by physical contact to the next position. So you do not have to be the expert programmer anymore. You don't have to know the programming code anymore. If you get a little bit familiar with the robot new interface, you can teach the robot easily new tasks with this kind of approach. And the safety. The safety is actually crucial for us. Robot has plenty of options to keep the work safe. They are all in a minimum category D or performance level D to keep the work safe. And really, last but not least, this is actually really the last part of this presentation, is the software and the possibilities of simulating the robot work. We're gonna have some nice presentations about digital twins today, but I will just mention that before even starting of installing the robot on a production plant, we always should simulate the robot work. In this kind of simulation environment, you can easily check what will be the cycle time, what is the potential collision points, even you can estimate the lifetime of the robot in this kind of particular application. So this was the just very briefly story about the possibilities of the robots. I wouldn't like to go again too much into the technical details, but I would like to stop in this place now. Thank you for your attention for this part of presentation. And now I would like to invite our partner, Tomasz Kwapis from ZMK Automation Company, because these were all the possibilities, but we have really use case from the Polish market with introducing and with running our robots in the production. So we will switch to Polish right now, if you don't mind. We will switch to Polish, and we will show you the story of introduction the M20 robot in ZMK automation company. Tomek?
Dzień dobry. Ja jestem... Chciałem przedstawić jakby historię wdrożenia u jednego z naszych klientów. Chodzi o... Tak naprawdę celem wdrożenia była automatyzacja produkcji jednostkowej, małoseryjnej. Mam tutaj na myśli elementy o wadze tak do 5 kg w seriach do 3 sztuk, znaczy od 3 sztuk w górę, więc mamy tak naprawdę produkcję powtarzalną, jednostkową. Jednym z głównych celów było też, aby cały proces automatyzacji obsługi maszyny był tak skonstruowany, tak skonfigurowany, aby możliwa była produkcja tych elementów w takich krótkich seriach przez 72 godziny. Chodziło nam o weekendy bezobsługowe z pełną kontrolą wymiarów i korekcją błędów. Elementy produkowane były to, duża z nich część to były to elementy aluminiowe, korpusy najczęściej do elektroniki, ale także stalowe elementy pomp, jak i zaworów. Wykonywane też były elementy z tworzyw sztucznych dla przemysłu spożywczego i nie tylko.
Ja może jedno słowo, proszę zwrócić uwagę, szanowni państwo, na tym zdjęciu. Bardzo ładnie to zdjęcie pokazuje wyzwanie, jakie stało przed stanowiskiem zrobotyzowanym, ponieważ to, co zrobiła firma ZMK, to jaki sobie cel postawiła, to stworzenie tak uniwersalnego stanowiska zrobotyzowanego, które będzie w stanie obsłużyć tak zróżnicowane detale, jak są pokazane na tych różnych zdjęciach. Te wszystkie detale, które państwo widzicie, obsługuje jeden robot, jeden system, jedno gniazdo zrobotyzowane. To się udało dzięki bardzo uniwersalnemu podejściu i takim przemyślanym designie zarówno robota, jak i chwytaka na przykład.
Żeby to, znaczy tak, może jeszcze tak, głównym z priorytetów w całym tym przedsięwzięciu automatyzacji było to, że z uwagi na to, że będziemy produkowali elementy w krótkich seriach praktycznie jednostkowe, to proces musi być, jak powiedzieć, jak najbardziej stabilny i powtarzalny. W żaden sposób nie staraliśmy się ścigać z czasem jednostkowym wykonania tych elementów, bo to nie o to tutaj chodziło, tak? W tradycyjnym podejściu to operator obsługuje maszynę, zajmuje się załadunkiem, rozładunkiem, wszelkimi czynnościami procesowymi, jak i kontrolą jakości. Tutaj to wszystko miało dziać się na stanowisku zrobotyzowanym. I teraz tak, co zostało jakby do zastosowania, żeby osiągnąć ten cel, który klient gdzieś tam przed nami postawił. Jako manipulator został zaimplementowany robot Fanuc, aby móc obsługiwać tak różną produkcję, bo tak naprawdę w planie produkcyjnym stanowiska mieliśmy wiele różnych elementów, tak? W bardzo krótkich seriach po kilka sztuk, tak? Więc tak też materiał przygotowany pod obróbkę był różnych gabarytów. Dlatego też został zastosowany system mocowań. Były to paletki lub imadła, takie na przykład jak firma Lang produkuje. Żeby dzięki temu, że mieliśmy, bo tak naprawdę klient wybrał sobie maszynę, którą by chciał zautomatyzować i nie była to jakaś najnowsza maszyna, która jakby od samego swojego powstania była do tego dedykowana. Była ze sterowaniem Heidenhaina, dlatego też powstało oprogramowanie bazujące na takim interfejsie Fanuc Robot Interface, to jest w pełni programowy interfejs, i bibliotece dla Heidenhaina do obsługi DNC maszyny. Dzięki temu mogliśmy zintegrować robota z maszyną tylko po interfejsie ethernetowym, tak? Więc nie musieliśmy tutaj jakby całą infrastrukturę już mieliśmy, tak? Nic i było to też bardzo efektywne kosztowo.
Sam robot, też może 2 słowa tutaj jeszcze ode mnie. Firma ZMK jest bardzo mocna nie tylko mechanicznie, ale software'owo, tak jak było widać na poprzednim slajdzie. Oni właściwie stworzyli od zera swój software do komunikacji na linii obrabiarka robot. Sam robot, bardzo króciutko, M20, jedna z bardziej popularnych jednostek 6-osiowych robotów. To jest jeden z bardziej uniwersalnych i częściej stosowanych na rynku robotów, zarówno do obsługi obrabiarek, jak i do małej paletyzacji, do niektórych zadań pakowania czy nawet montażu. Więc taki robot został tutaj zastosowany. Dlaczego taki? Dlatego, że partner stwierdził, że chciałby dobrać robota odpowiednio, przeprowadził najpierw symulację, co widzieliście Państwo na ostatnim slajdzie mojej prezentacji, czyli w środowisku symulacyjnym RoboGuide. Został ten robot wirtualnie zaimplementowany, zaprogramowany, zmierzony został czas cyklu i wtedy to był taki checkpoint, że ten robot na pewno poradzi sobie z zadaniem. Dlatego ten model, a nie inny.
Teraz krótko o efektach tej automatyzacji. W tradycyjnym modelu, tak jak rozpoczynaliśmy cały proces u klienta, wyglądało to tak, że maszyna pracowała przez 2 zmiany. Na każdej zmianie mieliśmy jednego operatora i całe stanowisko pracowało przez 5 dni w tygodniu. Taki zarejestrowany realnie czas pracy maszyny, tak, to było 14 na 24 godziny. Co tutaj dawało nam jakieś 280 godzin w miesiącu na tej maszynie. Po automatyzacji, tak, i jakby skonfigurowaniu tego całego procesu, nie tylko w związku z robotem, ale też zmiana technologii wykonania, troszeczkę zmiana programów na tych maszynach, osiągnęliśmy coś takiego, że jakby maszyna pracowała już przez 3 zmiany. Potrzebowaliśmy tylko operatora na pierwszej zmianie, który tak naprawdę szykował maszynę na 2 kolejne zmiany i monitorował jej pracę na tej pierwszej. W takim wolnym czasie, bo jeszcze zajmował się wdrażaniem tak zwanej pierwszej sztuki. Bo jeśli miał krótkie serie, pierwszą sztukę musiał po prostu wdrożyć, żeby później mogło iść to w trybie automatycznym. Stanowisko pracowało przez 7 dni w tygodniu. Maszyna pracowała przez 7 dni w tygodniu, bo operator był w stanie w piątek ustawić tak maszynę i tak było można skonfigurować pracę, aby uruchamiając ją w piątek, ona pracowała praktycznie do poniedziałku. Efektywny czas zmierzony na tym stanowisku pracy tej maszyny to było już 20 na 24 godziny, co dawało 560 godzin w miesiącu.
Po wdrożeniu robota.
Po wdrożeniu robota.
Po robotyzacji.
Więc mamy tak naprawdę 2 razy tyle. No i tak jak już tutaj wcześniej mówiłem, udało nam się dzięki, czyli to tak naprawdę klient wygenerował dodatkowe 280 godzin, no dodatkowych, tak? Dzięki robotyzacji, co dało mu w roku ponad 3300 godzin. Tak naprawdę takich godzin, w których on by bez tej robotyzacji w żaden sposób nie mógł wytworzyć, bo no nie miał dodatkowych operatorów, tak? Praca w weekendy też nie była możliwa. Według szacunków klienta wygenerował w momencie, gdy to stanowisko było wdrażane, ponad 700 000 złotych dodatkowego przychodu z tego stanowiska. Teraz tak, wdrożenie robota do firmy pociągnęło za sobą jeszcze całkiem inne skutki, bo przyniosło inne pozytywne zmiany w organizacji. Dużą taką zmianą była zmiana świadomości w ogóle pracowników, bo na początku ta robotyzacja była tak przez wiele osób jakoś jakby no może obawiali się tego, obawiali się, że gdzieś tam może być utrata pracy, ale po wszystkim jakby zauważyli, że jakby robotyzacja daje im możliwość pracowania troszeczkę na innym poziomie, tak? Wcześniej oni musieli obsługiwać, jakby to powiedzieć, fizycznie maszynę, później ich praca była bardziej taka, mniej fizyczna, bardziej jakaś koncepcyjna, tak? Bo oni na przykład wdrażali pierwsze sztuki, gdzieś trzeba dużo, no nie jest to takie jakby nudne. Inną taką jakby zmianą, bo proces robotyzacji, czyli sam robot jakby też nie załatwił, bo tak naprawdę robot obsługuje maszynę, tak? Tutaj ten proces robotyzacji wymógł na organizacji też to, że programy, które były przygotowywane na obrabiarki, plany pomiarów, cała organizacja musiała zostać dużo lepiej zrobiona, tak? I żeby wykonać, żeby obrabiarka mogła tak pracować, organizacja musiała wypracować te metody i te standardy. I te standardy naturalnie zostały przełożone też na inne maszyny w firmie. No bo tutaj robot obsługuje obrabiarkę, a na innych maszynach po prostu stoi człowiek, który wykonuje czasami podobne elementy, no ale on jakby zaczął je wykonywać też z innymi standardami, tak? Bo programy na maszyny były już przygotowywane na inne obrabiarki, tak w tym samym standardzie jak dla stanowiska zrobotyzowanego, tak? Czyli z pełnym pomiarem, z pełnymi korekcjami, ze wszystkim, tak żeby proces był w pełni stabilny. Żeby pracownik nie musiał co chwilę wyciągać, sprawdzać, czy aby ten element jest dobrze wykonywany.
Szanowni Państwo, też jeszcze tytułem komentarza, my nie bez powodu ten przykład wybraliśmy, ponieważ z jednej strony bardzo ładnie, tak jak widać chociażby nawet tutaj na tym slajdzie, czy na poprzednim, czynnik ekonomiczny, bardzo ładnie widać było, że przy zaangażowaniu robota do pewnych powtarzalnych czynności, ale już coraz bardziej skomplikowanych, możemy po prostu w pełni wykorzystać potencjał przedsiębiorstwa. Wykorzystujemy w 100% na przykład maszynę obróbczą, którą ma obsłużyć, a z drugiej strony to, o czym przed chwilą powiedział Tomek, zmiana nawet sposobu myślenia i standardów organizacji przedsiębiorstwa. Robotyzacja będzie pociągała za sobą po prostu w sposób nawet naturalny pewną zmianę kultury organizacyjną przedsiębiorstwa. Ciekawostka jest taka, co prawda będą po prostu operatorzy szli w stronę przekwalifikowania się, będą inne kwalifikacje się liczyły, będą coraz bardziej jakby pożądane takie cechy jak umiejętność dostosowania się do zmian. Ciekawostka jest taka, jedno z badań ostatnio, które widziałem, mówi o tym, że 80% zawodów, które będzie się liczyło w 2030 roku, jeszcze nie powstało, jeszcze ich nie znamy. Więc bardzo ładnie na tym przykładzie widać zmianę kultury organizacji, nawet przy relatywnie prostym zadaniu, jak obsługa obrabiarki.
Klient jakby po wdrożeniu ocenił, że zwrot z inwestycji będzie po 11 miesiącach przy zastosowaniu jednej maszyny. Tak? Tutaj była zastosowana jedna z maszyn z jego parku maszynowego, to była DMU 50 Evo, która już swoje lata przepracowała, ale do tego procesu bardzo dobrze się nadała. Bo był taki pomysł w trakcie tego projektu, żeby do robota dostawić jeszcze drugą maszynę. Wtedy stopa zwrotu skróciłaby się do 90 miesięcy i planowaliśmy tam wtedy robodrilla Fanuka, no bo mielibyśmy jedną maszynę 5-osiową, drugą 4-osiową i ona by bardzo ładnie uzupełniała cały ten proces. Dobrze. Teraz tak, automatyzacja obsługi tej obrabiarki nie skończyła się w tym momencie, w którym już jakby to ją obsługiwaliśmy, tylko powstał taki pomysł, aby w czasie, gdy robot stoi, oczekuje na skończenie się na wykonanie elementów przez maszynę, wykonywał jakieś czynności. Biorąc pod uwagę to, że jakby w tym całym koszyku tych elementów, które wykonywaliśmy, mieliśmy elementy zaworów na przykład, które wymagały obróbki później, szlifowania lub polerowania. To robot po prostu w trakcie oczekiwania na wykonanie kolejnego elementu mógł zacząć jakby wykonywać ten proces, tym samym odciążając kolejne takie manualne stanowiska, gdzie to człowiek musi tą czynność wykonywać. Dzięki wdrożeniu takiej obróbki oszacowaliśmy, że to jest kolejne 240 godzin w miesiącu do odzyskania w tym czasie, gdy ta maszyna pracuje, czyli w takim czasie równoległym, tak? Jakby rezygnując z tej pracy ręcznych tych pracowników, tudzież zmniejszając jej ilość.
Czyli znowu jakby wykorzystując całkowicie potencjał, który daje nam robot na danym stanowisku, proszę zobaczyć, ile nawet samego tego prostego faktu wykorzystania możliwości technicznych robota, ile uzyskujemy po prostu realnie przepracowanych przez niego godzin w miesiącu. Niech ten robot nie czeka, nie stoi, niech w czasie oczekiwania na detal wykonuje już inne operacje, niech bierze udział w przygotowaniu produktów, niech bierze udział w obróbce wykańczającej, w tym samym czasie w tle dzieją się inne procesy, ale robot nie stoi, pracuje, efektywnie dając nam kolejne roboty.
No i może pracować 7 dni w tygodniu.
I może pracować 7 dni w tygodniu.
Projekt cały czas u klienta żyje. W tej chwili z uwagi na dużo większą dokładność elementów i też przez to, że klient widzi jakby wartość dodaną tego całego tego stanowiska dla swojego biznesu, została wymieniona maszyna, tą, którą robot obsługiwał z tej demo, na Hermet C32. I dzięki temu, że wcześniej ta maszyna też jest ze sterowaniem Heidenhaina, bo tak też została zamówiona, i dzięki temu, że mieliśmy tak całą integrację wykonaną, tak, to przeniesienie robota do innej maszyny to było niecałe 48 godzin, tak? I to jest też dowód na to, że robot może by zostać, czyli historia robota nie kończy się z historią projektu, tak? On jest w pełni uniwersalny, tak? I możemy go po prostu jako manipulator, możemy go bardzo łatwo zaadaptować do innego projektu w momencie, gdy jeden się kończy, tak?
Czyli inaczej mówiąc, elastyczność, o której już kilkukrotnie tutaj dzisiaj mówiliśmy, to jest właśnie to. Jedną z większych cech, jednym z większych plusów robota jest możliwość jego uniwersalnego wykorzystywania również do innego stanowiska, innej obrabiarki, a czasami do kompletnie innego procesu. Szanowni Państwo, bardzo dziękujemy za tę część prezentacji. Wrócimy na chwileczkę do części związanej z ideą przemysłu 4.0, a nawet jak było widać 5.0, więc zapraszamy z powrotem na scenę Jędrzeja Kowalczyka, któremu oddajemy głos. Przełączymy się teraz z powrotem na język angielski, żeby nie było zbyt nudno. So we will switch back to English now, if you don't mind. And Jędrzej Kowalczyk will continue with his next step of Industry 4.0 now.
Okay. So thank you and welcome again. As we already said, it's quite important to not only connect the machines, but to think what we can realize thanks to that and the software, the systems which we would utilize. So generally the industrial Internet of Things give us a lot of opportunity thanks to the analysis of the big data, the raw data. And because of this opportunities is so much, we need to think always about our objectives, our opportunities. Here are some examples, but what's the most important is to prioritize them. Because quite often when we discuss with our partners, customers, they want to, of course, connect the machines, get the data, maybe monitor, visualize them, but for what? And then the problems come. Because generally they don't know what the KPIs are quite or even most important for them. So if we take a look on such some examples of the factory, we've seen that on our shop floor, on the operation technology, we've got a lot of possibility to generate today the data because almost each machine is equipped with any kind of processor which generate a lot of data. And then we can back with it to some other softwares which could answer for our needs. And as an example, just because it's too much to show everything, but what we are focused, how we do it in Fanuc right now, and this is our practice, which we usually talk with our partners, are three things. The first one is predictive maintenance, but not only. Thanks to the software of ZDT, Zero Downtime, we can generally monitor the mechanical health, the process health, the system health, and of course the maintenance health. There was today a very nice slide shows the OE, how it works when we use different types of the maintenance and how we plan it. That's why one of the most important is the predictive maintenance, which offer us to understand the mechanical health and general system health, and to get a chance to predict when the failure could appear. Thanks to the ZDT, we can find out any failure of the robots 2 weeks before it happened, and this gave us an opportunity to generally schedule the service intervention before the downtime, and we can save a lot of time during it. Downtime means not only no production and no money because of it, but quite often also a huge penalties because we cannot deliver the production which we contracted. So next thing is, of course, the operational performance. We can monitor easily our status of the robots, but quite important topic today is also the power consumption. So the software optimize the power consumption usage, and of course, what is very beautiful, thanks to the power consumption monitor, we can also understand our production, because one customer was really surprised that the robot is not working every 1 hour per shift. And he was surprised why the robot is not taking the energy. And generally, that was a time when the programmer was modifying the programs, but this could be easily done by the 3D simulation software and just copy-paste these programs to the robots. So after some kind of process optimization, the customer get 1 hour per shift more of the production, which thanks to only this 1 hour, those software return of investment was in three months. But as I already said, the robots, it's only like, we can imagine it's only like an engine in a car, but it's not a complete car, yeah? Because we've got a much more equipment, machines, like on the previous great success story we've seen, or for example, the power source for arc welding robots. So we also need to monitor those parameters if the quality and the process goes correctly. And based on that, we can only optimize our production. Next nice example is the vision system monitoring and the general production traceability. We can imagine that sometimes the scoring of the vision system goes down, and based on that we can react before the robots stop and not work anymore. It can be, for example, that the lens are dirty or anything else around the system, but we can also work on it. So generally, we can think that the software like ZDT is for future. It can work with us for the future steps. It's generally predictive maintenance, but also all the future system status. But also, it's of course good to know our history and what is going on actually. So the next example is the MT-Link Eye, which allows us to monitor all the products, not only, of course, Fanuc, but everything what exists on the production side, to know the status, to track the traceability, to again analyze the energy consumption, not only about the robot, but also all other equipment on the robot cell. So those systems are quite simple, easy to connect, but give us a chance to make our production more visible. And what is most important, if you already set up our priorities, we can easily make a nice dashboards to understand the situation. And which I already also said, the AI, also the machines on the world more and more are changing the drive systems from the hydraulic or pneumatic into the just electrical ones because of the energy and precision, flexibility which it offers. And many machines are equipped already with the CNCs. So also we want to focus again a little bit wider. So we can offer the AI servo monitor, which analyze any anomalies which can appear during the production. And the system completely, thanks to the machine learning, and can set up the probes by itself, analyze, and find out what's going on. Of course, there is needed the knowledge about the production machine, for example, because even if we know that, for example, the current in the servo motor 6 is not okay, for many of us, this knowledge will not offer too much, but for the machine tool builder, this will give a great opportunity to check more details what's going on. So those systems are just an examples. It's much more. We've got a nice software which create our partners, our even sometimes customers create their own softwares. So generally, we need to think how to reduce the downtimes, and this is very important because it costs a lot, but also how we can work on the continuous improvement, which also was shown on the previous example, because without continuous improvement, generally, we never can follow up the quickly changing times, and the system cannot be closed. So this gives us a possibility to increase all the, we call it growls of the manufacturing, yes, like OEE and other KPIs, but most important is to understand that the production is very, very wide, and quite often, even today, we've seen that we don't connect just our shop floor, but between even the factories or the producer and the supplier, the communication can already exist. So to close it also and understand a little bit more, I would like to invite Piotr, which will present a bit about the first platform of the world as a digital platform of the digital twin, but also marketplace for robots, and a really great opportunity to make it much easier, find out where we should invest and how to do it. Thank you.
Thanks. If I can still on the remote. Yeah. My name is Piotr Wiśniewski. I'm the CEO of DBR77 Robot Platform, and I would like to draw your attention in the last couple of minutes. I know that after 2 days, it will be pretty hard to take your attention, but I will tell you a completely different story. We had 2 days, or actually one very solid day of the presentation about the technology, especially the previous one. I was not aware about such complicated site which we can use in our factories, but I would like to show you a completely different perspective. But before I will go that, there is a question. I will check how closely you are with the topic. How many robots currently we have on the world? It was on the slide. 3.5 million. We have 8 billion people around the world. So we are here because we would like to find a way how we can make a democratization of robotization, how we can find a way how we can put more robots on the production floor. And this is the story of DBR77. Couple words how it starts. First of all, I was 5 years the CEO of global organization. We were tier 1 producer of parts for passenger and truck cars around the world, as you can see on the map. And I have a store in China, India, Mexico, Brazil, and many other different places. And you know what we recognize? We recognize that it doesn't matter where we are. The process of investment in the new production station looks more or less the same. Look, we have six stages. I do hope you see that on the slide. First of all, we have a specification, what kind of technology we expect, and we have to find the technology. The first step takes normally around 1 month. The second step around 6 months, yeah, because we need a lot of time to write proper solution for us. Then we have to make a decision. You know perfectly the process of decision is always very difficult, especially when we are a big organization. People spend a lot of time of discussion. That we have to contract the station. Finally, we can invest, and finally we can put that implementation on place, which normally takes like 6, even 9 months. And finally, we have to optimize that, because when we put the robot on the station, it doesn't mean that the story is finished, how it was presented a couple of minutes ago on the case. And you know what is also interesting? It normally takes 25 months. We think that it takes like 6 or 9 months. And also interesting point is that around 60% of total investment, that is actually the cost of the robot or of the station, but there's plenty of other costs which we have to cover if you want to invest. Yeah, so we look at that story and we ask ourselves what we can do. And there is the story of digitalization. We ask ourselves what is changing currently on the world. First of all, there is of course connectivity, a lot of data, and also computing processing, which is growing, and we spoke a lot about that today. What is the result of that? The result is that we have, in fact, 3 dimensions of transformation. We spoke a lot about processing digitalization. We spoke about robots, about Industry 4.0. That's a great point. But we look at the story and we ask, we recognize this is not the end. Look, we have also digital products and we have a lot of new business models. And we wanted to be there. We wanted to find a way how we can respond for that huge challenge. Why only the biggest suppliers are able to invest in robotization? And we created all-in-one platform for the best robotization, which cover in fact 3 pillars. First of all, we have our own digital twin. We speak a lot about digital twins here today. I will show you the right solution because we finally have such solution. Then we also implemented AIs on our digital twin. You know, it was also presented many times today that we have AI and we have to think about that. I will show you that solution. And the last point, which I believe is the solution for the topic, is a marketplace. The marketplace, which we used to call that we want to be the Amazon of robotization. We want to connect from 2 sides of the market players. From one side, we have manufacturers. Yeah, manufacturers which normally think, maybe this is a time for robotization, maybe I'm ready or not. From the second side, we have a robot technology suppliers and integrators. And very often, there is a huge gap between them. So we wanted to create a marketplace which can respond for that challenge. And we did it. And I will show you what was the result. Remember the first moment was specification. In the old world, the specification looks like on the left side of the slide. So we have to create a lot of drawings. It takes a lot of time. It was a lot of discussion, which has to be there. First of all, it was static 2D dimension drawing. Yeah, so of course we can present many things on such two-dimension graphic, but this is first of all static, and second of all we cannot predict many things. So we launched our 3D studio, which you can see on the right side. When you can make, like, there's another question. Have you ever played any 3D games when you have to kill somebody, or? Yeah, many of you. And I'm sure you are pretty familiar with the technology. In our 3D studio, it's very, very easy to take all 3D models, put them on the floor, and also prepare the complete flow of the material, of people, of any kind of robots and machines. So we can make 3D dynamic design, which takes, first of all, much less time than the previous option and can be much more accurate. Let's go further. We have also our small AI, which can help us to make a specification. Yeah, we don't have to check 100,000 databases to understand what kind of investment we have to do. Our platform asks you what kind of production you have, how the production is organized, what is the time of the production, and ask you a couple different questions which should be absolutely necessary to make the analysis of the investment, and we don't have to lose so much time. So that was the first step, how we would like to, first of all, reduce costs of that implementation, and second of all, also the time. Then technology. On the right side of that slide, you can see how the work looks 10 years ago. Yeah, we spent a lot of time, which was pretty nice. Yeah, I'm sure that many of you have great memories from parties or many kind of events like that, but it was a lot of time and it was quite expensive also. Nowadays on our platform, you can find absolutely every kind of suppliers of technology. Thanks of our friends like Fanuk and Kuka. I don't remember if still we have Kuka team, great. We have at that moment all global robot suppliers on our platform, and you don't have to call to all of them, and you don't have to travel to any kind of events. All of them can suggest on our platform their technology, which can work pretty well. And I have example for you. That's that stage which you that station which you currently see. Something which is very actual. It was prepared a couple of weeks ago on Fanuk solution, but it was also prepared on different kind of technology. Very easily we can check in the same place and compare which technology will be optimal for such kind of story. Then we have to make a decision. Yeah? As I said, decision processing is always in the big organizations, especially very difficult. It is time consuming because we have to compare. And in the old world, we got a lot of effort in different way prepared, in different programs prepared for us, and we were not able to compare them. On our platform, it's very, very easy to compare any kind of offers which were prepared by many different suppliers and integrators. And we compare the concept on 3D models, and also we can compare, and mainly we do that, the financial and operation analysis. We can compare what will be the time which the station has to work until it will be paid back, or also what will be the impact on OE, the topic which was discussed so much today. Yeah, so yeah, we can make a decision process much faster. And this is also game changing. We spoke today a lot about digital twin, perfect, but you can see on that movies that what was prepared by us on our 3D studio, on our PC, you can also be presented on VR and AR. What is the story here? AR is a great solution. If you want to see if the station or the solution, robot or some other different technology will match to your production factory, to the line, you can take your tablet or smartphone or Google Glasses. You can go there and you can check how it will match to the existing infrastructure. But VR, it's something which is really game changing, because everything what was designed on our studio can be, you go completely in that virtual world. You can be immersed in that case, and very easily you can move every single machines, people, and make complete analysis on the concept. What is also important, it takes seconds to make the synchronization between networks. So yeah, it's pretty easy to make decision that we have to go with contracting. And in the previous word, we discussed a lot. Yeah, lawyers can take a lot of time and cost us a lot. And many of our partners complain that, yeah, we never know how to do the business, but lawyers and lawyers and lawyers. What we did on our platform, the whole contracting part is also organized on our platform. We have standard documents, and very easily and very quickly, two sides can make a deal, and it works pretty well. This is a slide when we are particularly very proud, because there's a number and list of our partners. So, you know, if you want to buy the technology from one of them, it can be done by our platform. So you can see how easy the contracting can be. Then the first stage, the moment, was implementation. Our platform helped a lot. I mean, we have all project management system there, so all project can be tracked. Yeah, but also important point is, which I cannot mention so much in that presentation, that when you want to buy solution for our platform, you can compare and you can compete. So of course it means that you can buy solution much cheaper than in previous word. And the last point, very specific important point for our meeting, is our concept of Lean 4.0. This is our digital twin with our AIs. When finally we have that station ready, yeah, and the robot, it was implemented, we are happy, everything is run perfectly. The next day we should ask ourselves how we can operate better, how we can reduce more times or reduce the minutes which the station was stopped. In the old way, yeah, before digitalization, we have a procedure which we called VSM, value stream mapping. How it worked? Well, guys from automotive know that perfectly. We have to find long batches of the production, then we can make a complete analysis step by step. What is the timing? We can calculate where is the bottleneck, and we should focus with our lean methodology on the bottleneck. That was the story from last 30 years, yeah. But the problem is the words change a lot, and our batches of the production are much shorter at that moment. So all of that concept doesn't work so well. So we had to find a solution. And this is exactly the concept on Lean 4.0. That concept is quite simple. We collect data from any kind of equipment, any kind of sources which create data. What exactly it means? That we can take data from robots, from machines, we can take data from our final goods or materials which are rotating on the factory. And finally, we even collect data from people, from operators, when they are located and what they do. I can give you some examples. A couple of weeks ago, we finished the project when one of our clients checked the operators, what they were doing, and recognized that 2 hours and 45 minutes every single shift, average operator was not on his plate. Yeah, so it means that more or less 30% of the salary he took from completely nothing because he didn't work. Yeah, so we can make such analysis, and also what is important when we have data in the next step. I have such slide. In the next step, when we collect data, we can make finally reports in 3D Studio with perfect analysis. When we make the analysis in 3D Studio in digital twin, as you can see here, we collect all kinds of data. We can simulate complete system of the factory and also the warehouse. So in the next step, we can make a planning, how we will operate. What kind of planning we can do in our 3D at that moment in our digital team? First of all, we can do a production schedule. Also in the middle term production schedule, we can make a scheduling per line. We can analyze who should work well. We can balancing lines. We can make a complete analysis on the intralogistic, which material should be where and when. And what is also very important, we can do it exactly at that moment when the information change. So when we have planning, we can make a complete simulation. And simulation, this is almost the AI, because when we can simulate, we can recognize which solution is optimal from the perspective of numbers. So we have digital twin. Yeah? What is the story with digital twin? Why we should create digital twins for our factories? Because we can finally treat, and you can believe me, it was impossible 3-5 years ago. This is happening now because of the technology which is in our range. We can make the complete visualization of the system on the production. We can make simulation. Means also that we can avoid a lot of mistakes in the planning of the new line, but also in the new factories. And currently our platform is used mainly because of that. We can make a simulation of the production cells, complete lines, warehouses, interlogistic, and also we dream about, and sometimes we do that, digital twins for complete production factories. But digital twin without AI, this is, let's say, 40% of the job. So we have algorithms, which I explained a couple of minutes ago, which can help us to make the decision in the right moment, in the right place. And now you can see how digital twin can look. Yeah, this is one of our cases when we can present exactly on complete production flow, times, what people do, and on the right side you can see simple reporting what the stations were achieving. And this is the result, if you can look at the screen. Step by step, we started with 1 month of specification. It takes minutes at that moment, at least 2 hours, yeah? So the cost is reduced. Technology, we need 6 months. We can make currently, and there are data from our platform, 2 months to make many cycles of discussions and negotiation with engineers from many different suppliers. And in 2 months, we can achieve the level of knowledge about the future technology for our plant, which normally in the old world we need at least 6 months. Yeah. Then decision in our case, especially in VRs, I have to tell you that all bosses, when they are in VR, they see, wow, this is the concept. We want to do it in that way. So the decision is made. It's normally made much faster. Yeah. Then contracting we reduce from 6 months to from 3 months to 1. Implementation, we reduce from 6 months to 5, and finally the optimization, we reduce from 6 months to 3 months. But in fact, this is a process which we never ended. What is the result? The process which took 25 months normally takes like 12 months, like 1 year. But also we were able to reduce the cost by 30%. And this is the last slide. What we did, we create a marketplace with digital twin, which is able to reduce the level of investment by 30%. We can reduce the time which is needed for that implementation by half. And what is also important, the average efficiency can be improved by 20%. And as you can imagine here, there is no any investment in any kind of machines. There is only the knowledge which finally can be used on our platform. So if the story can be interesting for you, please feel invited, tbr77.com. This is our website, and you can find all of the solutions, which is also at the end very important. We don't sell it as a program. We are the platform, we sell it as a service. So the barrier of entrance for us is really very low, because we sell it like Netflix, I mean in the subscription rate, yeah? So we don't have to invest in another millions like our competitors, but only 300 euros per month, and you are in our digital world. Thank you very much for the time. And Jędrzej will make a summary of our presentations.
Thank you very much, Piotr. So we are coming to the end, and I've seen a very nice way of the investment, how to do it in much easier thing. We believe mostly because of the generally, what we can say, we don't need to be such an expert during the investment like in the past, but still investment in robotization is quite important topic, and it's mostly must be very, very well prepared because we manufacturing mostly not because we like it. It can be also possible, but quite often because of money. So how we look on it is that we find out five steps starting from processes, and just on the end of those processes we analyze very deeply the return of investment, if it's worth or not, because sometimes it's the thing that the investment maybe is not okay. Maybe the other point of view is much better. So about the processes, it's important to fully understand the environment in which we are working. We've seen the automation of individual almost production, which quite often makes no sense to use, for example, standard way of lean, but more often the theory of constraint. But it can be also completely opposite side. When we find out the processes, many times when we start working with our customers, we've seen that there is not the time to invest in robots. We had to wait because the processes were so, I don't want to use the bird words, but generally, first we had to clean up the shop floor and optimize the flow on the production, and because otherwise the investment in robotics will never return. So that's why it's so important to find out, we call it bottlenecks, but also to generally think how we produce. Many times, even one thing also important is that we look on this OE parameters, but quite often we've seen that even if the OE is quite okay, the question which quite often we don't ask is, what is the cost of such good OE? Because sometimes if customer knows this is the bottlenecks, okay, the OE is 18, even 90%, but the question if the investment in this point is not too much. So we really should analyze with financials people very deeply about the thing. As in my first presentation, we spoke that right now the manpower is returned to the factories, which is very important. And that's why we really need to secure the resources, not only on the investment steps, when who will utilize the system, but also how it can support our people from the safety point of view. Maybe the great added value of robotization was the change of the technical culture generally in our manufacturing. This is also a very important point. And again, we're back to the processes, because quite often one process on the production which start to be automated must also need also very well prepared production on the before steps. The technology, we really like to work with data, hard data, not promises and general. This is great. This is easy to program. You know, such marketing things are nice, but we really always like to calculate everything, because all investment can be generally quantified and analyzed very deeply. And this is also not about the technology, but also about the partners which will deliver this technology, the system integrator, robot producer, PLC producer, all the things around, maybe software, the connectivity and the platform. So all those things must be really well and reliable, depends of your business needs. Mentioned a few times, but this is one of the toughest point, is the connection between the IT world and OT world. Not because of the technical features, because of us, because many times people from IT cannot understand OT and opposite, and very tough to discuss, because when we don't understand something, quite often we just say no. This is the simple way to stop it, the investment. That's why the education is such an important thing, and to understand how to proceed. And just after all those points, all this analyzed to find out where we are and how we do it. We've seen great visualization in 3D, which speed up, thanks to DBR, very much the investment. But just on the end of it, we can really make a return of investment analyze and answer the question, is this is a good place to invest. As FANUC, we use a ROI calculator quite often. We are surprised still that not change or reduce the manpower is the main factor which make the investment, the results of the investment, but because of the production volume increase. And of course, if there are some customers which don't know how to sell more of one product, there is a little bit of problem. But if somebody can sell more thanks to the same production, the production increase, the capacity makes the ROI calculation the best one, because we simply earn much more money per each unit. And quite often the production increase thanks to robotization is not like even 20, 30%, but quite often we are surprised that it's really double or even more. So really open to discuss always the investments, but we understand that we really need to prepare for it. And it's not changing just from one day to another day, because even as FANUC, for example, we've got one servo factory, which is fully automated and can work more than a month without any human touch. But generally, we were working on it almost 3 decades. So the changes from standard way to fully automation takes time. So I would like to thank you, and also thanks to my partners. I hope we could support. We are always welcome to discuss further. And I wish you a great afternoon. Thank you very much.
So it looks like you are 10 minutes ahead of time. So maybe some kind of discussion, questions? I don't see any. Okay, so this concludes this session, and we are waiting then for the chairmen to, in about 10 minutes, to come here, and we will conclude the whole conference. Mr. Krasiński, maybe you would like to make some announcements? No? Okay, so this concludes this session. We finish now, and we'll meet at 3:30 to conclude the whole CETEF forum.